Dear friends of the sun, buckle up, lean back, and grab a milkshake, a coffee, or maybe some tea, depending on what you're in the mood for. Today, we're embarking on a journey to one of the most fascinating objects in our solar system, the planet Saturn and its incredible rings. What's really behind these rings? How did they form? And why have scientists been intrigued by them for centuries? All this and more will be revealed in this video, so stay tuned as we dive into the world of Saturn's rings. The discovery of Saturn's rings. In 1610, Galileo Galilei discovered Saturn and described it as an object flanked by two small companions. However, due to the limitations of his telescope, he couldn't see the true nature of the rings. In 1655, Dutch astronomer Christian Huygens, using an improved telescope, made a groundbreaking discovery. He realized that Saturn was surrounded by a flat ring which didn't touch the planet, a revelation that laid the foundation for further research on Saturn's rings. The Saturn rings, fascinating structures of ice and dust. Saturn's rings are primarily composed of tiny water ice particles, ranging from the size of dust grains to several meters in diameter. These icy particles reflect sunlight, giving the rings their brilliant appearance. Additionally, there are impurities like dust and organic compounds, which give the rings various hues. The main rings and their structure. Saturn's rings are traditionally divided into 7 main components, labeled A through G. These rings are not only impressive to look at, but also serve as a prime example of the complex physical processes at play in the universe. A ring. The outermost and one of the widest rings, known for the Cassini division, a notable gap caused by the gravitational interaction with the moon Mimas. B ring. The brightest and most massive ring, featuring a variety of structures such as spokes and waves. C ring. A relatively weaker and more transparent ring, located inside the B ring. D ring. The innermost and weakest ring, closest to the planet. E ring. A broad, diffuse ring mostly composed of microscopic ice particles from the geysers of the moon Enceladus. F ring. A narrow and dynamic ring held in place by 2 shepherd moons, Pandora and Prometheus. G ring. A faint and broad ring situated between the F and E rings. The dynamics of Saturn's rings. What's really happening? The rings of Saturn are a dynamic system, influenced by the planet's gravity and that of its many moons. These gravitational interactions lead to remarkable phenomena, such as the famous spokes and waves in the rings. Shepherd moons and their role. Shepherd moons play a crucial role in maintaining the structure and shape of Saturn's rings. These small moons, such as Prometheus and Pandora in the F ring, exert gravitational forces that keep the particles in the rings in their orbits, preventing them from spreading out or clumping together. The Cassini mission. New insights into Saturn's rings. The Cassini-Huygens mission, launched in 1997 and reaching Saturn in 2004, revolutionized our understanding of Saturn's rings. With fascinating discoveries such as propellers and spoke-like structures, Cassini dramatically expanded our view of the rings and provided deep insights into their complex structure. Propeller structures. These are formed by the interaction of small moon fragments with the ring particles. Spoke phenomenon. Cassini confirmed the presence of radial structures in the B ring, known as spokes, which are likely caused by electrostatic charges. Composition and density waves. The mission provided detailed information about the density and composition of the rings and showed how they are influenced by gravitational interactions. The formation of Saturn's rings. How did they form? There are several theories about the formation of Saturn's rings. One theory suggests that the rings are the remnants of a moon that was destroyed by Saturn's tidal forces. Another theory speculates that the rings are leftover material from the original formation of Saturn and its moons. The age of the Saturn rings. The age of Saturn's rings has been a subject of intense scientific debate. Earlier studies suggested that the rings were relatively young, possibly only a few 100 million years old. However, more recent research and data from Cassini indicate that the rings could be much older, perhaps as old as the solar system itself. The future of Saturn's rings. How long will they last? While Saturn's rings are an impressive sight right now, their future is uncertain. Through a process known as ring rain, the rings are continuously losing mass. What does this mean for their long-term stability? And what could future missions reveal about their formation and evolution? Conclusion: Saturn's rings, a fascinating cosmic wonder. The rings of Saturn are more than just a visual spectacle. They are a fascinating scientific phenomenon that provides crucial insights into the universe and the formation of planets. With each new discovery, we are one step closer to understanding these cosmic wonders.